Hi everyone, let's move to the next topic, that is fourth chapter, calculus of variations. Okay, so in the calculus of variation, first we have to see why we are using the calculus of variation. See here, here they are showing the curve A to B. We have to move from A to B, that is B is there. Okay, so with respect to the minimum time and with respect to the shape also, minimum shape also, we have to move from A to B. So we have to select like that by using the calculus of variation theorem. That is the connection with the optimal control problem. We seek the control function and minimizes the performance measure we have to consider. Okay, so first we have to see some definitions, some important terms, that is in the fundamental concepts. Okay, the fundamental concept means what? In the optimal control problems, the main object is to determine the function. So in this concept, main object is what? To determine the function in the given problem. Okay, in the whatever the problem is given, in that problem we have to find the function. First we have to find the function. That function should minimize the total function, specified function. Okay, means how to select that function? That function should minimize a specified functional. So that is gives the performance measure. Is it clear? The analogous problem in calculus is to determine a point that yields a minimum value of a function. In this section, we have to introduce some concept, that is a mean, what is the function, what is the functionals. We have to see the definition, that is in terms of linearity and all. So mean, first term is what is the function. Okay, so what is the function means what? If you take f is a function, it is an element, it is having the elements q1, q2, q3, that is q number of elements in the set of D, in the D set, in the range, that is the in the range R. D is called what here? Domain, and R is the what? Range. F is a function having f equal to q1, q2 value in the domain D, in the range R. Okay, that is the what function we call it is. Suppose here n number of Euclidean space, that is q1, q2, q2 up to qn numbers are coordinates of a point in a Euclidean space. The f is having a q1 function, and also q2 it belongs to D and it belongs to R. This is we called as a function. For example, they have given f of q in Euclidean space. We have to write that the distance of a point q from the origin. Origin means q1, q1. Q2 means Q2 into Q2. Origin you have to take same Q1 into Q1 origin. Okay, so for the Q2 origin means Q2 into Q2. So Euclidean space you have to take the root of origin, that is Q1 square plus Q2 square, like this. Okay, so what it means, the functional we have taken as a J. Okay, it assigns each value, that is each function x in a certain omega, a unique real number, that is this is called as a domain. Here instead of D we are taken as omega as a domain. Okay, in the range of a function. Functional means what? Whatever you have to consider as the functions. Okay, just now we have defined a function. So in that function, how to define a function means it assigns each function. See, f1, f2, f3 are nothing but a function. So j is a what? Functional. Therefore j is equal to what? j1, j2, j3 means this functional define each value of function. So here function andre ile entagondare x antagondare, means x1 is a function, x2 is a function, x3 is a function. Therefore j is equal to what? It assign each function, right? That is functional. So they have given here functional. Each element means each function means what? From first to last. So x is the what? Function. J is the what? Functional. So j functional is equal to it assign each function from first to last. That is we have to take on as integration, right? It is a function and this is the what? Functional. So next is what? Linearity. Linearity means what? Example they have given here. So see here, linearity, it is a function f, it is having a q numbers, it belongs to D and it belongs to the range R. It holds the principle of it satisfies the principle of homogeneity. What is the principle of homogeneity? F of alpha q equal to alpha into f of q. f of alpha q equal to alpha into f of q. Whatever they give the one problem, you have to first check. If they ask linearity of the function, means check principle of homogeneity is satisfied or not. Means you have to check f of alpha q and also write alpha into f of q. If both are same, that is homogeneity principle satisfies, right? So here the principle of additivity. Principle of additivity means f of q1 plus f of q2 equal to f of q1 plus f of q2. So if both values, if you get the same, then that is the principle of additivity. They have given here example, see here. They have given here if f of t is equal to 5t. Okay, f of t is equal to 5t. What is our principle? F of alpha t equal to alpha into f of t. Same rule you have to apply here also. F of alpha t is equal to f of alpha t equal to, means t you have to replace by alpha t. So 5 into alpha t. But this one is over. Next, alpha into f of t. Alpha into f of t equal to alpha into 5 t. Function is what? 5t. Function is 5t. So whatever t is there here, alpha into function is f of t is what? 5t. Therefore, see here both are same or different. 5 into alpha of t equal to alpha into f of t. Both are satisfy the our principle of homogeneity, right? Next, apply principle of additivity. F of t1 plus f of t2 equal to f of t1 plus f of t2. Satisfies or not, here check it. Alpha f of t1 same, you will get same whatever is. Okay, this is also holds good. Next, one more example they have given here. The function is what? 2 by t. 2 by t, check whether the principle of homogeneity is holds good or not. Okay, see here, g of alpha t, g of alpha t equal to t divided by alpha into t. Okay, this is what they have given here. Function is what? This one. Function is what? This one. So we have to check whether it is same as the principle of homogeneity. Okay, sorry. So this is the what? Our function f of t. First you have to check this is the what? Here instead of f they have given here g. Instead of f they have given here g. Therefore g of alpha t. Here they have given function this one, g of t equal to, right? G of alpha t equal to, shall I write here, g of alpha t equal to 2 divided by, the given question is what here, g is equal to, g of t is equal to 2 by t, right? So replace t by alpha t. See here, okay? So like the same, g of alpha t equal to t divided by alpha t, right? 2 divided by alpha t. This is the equation number 1. So this is over. Next, consider this one, alpha into g of t. Alpha into g of t means alpha this one. G of t means what? G of t is 2 by t into 2 by t. This is equation number 2. Compare this equation number 1 and 2 here. These both are not equal. Therefore, it is a principle of homogeneity is failed here, not satisfied. Therefore, function g is a what? Non-linear function. Okay. Similarly, next, j is next definition. J is a linear functional of x if and only if it satisfies the principle of homogeneity. Is it clear? Just now we have written in terms of function and functional. Linear functional means you have to apply the linearity principle, that is denoted by j of alpha x equal to alpha jx. Okay, same thing you have to write for the additivity principle. Again you have to write same for the functional also. Okay, principal homogeneity for function, functional, additivity, and this is what expression. See here, this is one more example, g of x equal to t naught to tf x of t. This is what function and this is what functional. So principle of homogeneity, this one holds good or not, you have to check it. J of alpha x, okay, j of alpha x and alpha into j of x. J of alpha x equal to, So whatever x term is there, you have to multiply alpha. J of alpha x equal to alpha into x. Next, alpha into j of x. Alpha into j of x means you have to take alpha into j of x equal to alpha into this is what j of x. See, both are same or different? Both are same only. So it is the principle of homogeneity. Then come to the additivity. Same principle for the additivity, right? So j of x1 plus j of x2. Just now same thing you have done for the function, and this is for the functional, right? Functional j, integration of t, x of 1 plus x of t. Both are integration, separate you have to take it, right? You can write separate these two. So principle of additivity, this one. So next consider the functional g of x equal to integration 0 to t naught to tf x square of t dt. So here see that they have given j of x equal to, or they have given integration x square of t dt. So apply here the principle of homogeneity. What is our principle of homogeneity? J alpha of x equal to alpha into j of x. This is our principle, right? So first you have to consider this one, j of alpha x equal to, so jx of is nothing but this one, right? J of alpha x equal to t integration from t naught to tf, okay, whatever is there, alpha into x of t whole square dt. So whatever x term is there, you have to take it as a alpha term. Here instead of x, you have to take an alpha x. So whatever x is there, here alpha into x, that is alpha square x square, right? So you will get here alpha square x square dt, right? Next term is second term, alpha into g of x equal to alpha, right? G of x means this one, integration x square of t dt. See, these two are not equal, hence this not equal. Principle of homogeneity not satisfied in this concept, right?